Alright, what's up guys? Mr. Fabella here again. This time starting a new chapter on functions. We're going to go kind of slow a little bit, but first we're going to explain what a function is and then talk about function tables. So let's start with what a function is. Okay, so we're going to look at some definitions here. Function, function rule, function table, independent, dependent variable. A lot of different vocabulary as we're starting. So I'm probably going to put the definitions as we go up here, just so it'll be kind of easier to follow along. But first, function. So what is a function? So it's a relation that assigns exactly one output value to one input value. So let's say the number of wing beats is the output, depends on the number of seconds, which is the input. Okay, if you're parking somewhere, the amount of time, the amount that you have to pay is the output, and the input would be how long you've been there. So that leads us to independent and dependent variables. So I'm kind of skipping around here, but let's go with that example of a parking garage, right? You are at a parking garage, you kind of have to pay. Let's say it's $2 per hour or something, right? So your input is the time, how long you decide to go there. Let's say you are there for 4 hours. You're at the parking garage for 4 hours, you leave your car there, right? That is your input. A function happens, and your output is going to be how much you have to pay. So if you're there for 4 hours, times 2 is going to be 8. So your output is $8. So that is also, so input and output, that can also be your independent and dependent variables. So independent variable is the input. It's independent. So independent means it doesn't depend on anything else. So time is usually independent. Nothing really affects time. Time goes on, right? Dependent variable is your output. So the amount of money you pay, that's your output. It depends on how much time you spent in the parking garage. So that's independent and dependent. So input is independent, output is dependent. Your output depends on what your input value is. Okay? All right, the other piece of vocabulary here is a function rule. So that describes the relationship between the input and output. So in our example about a car garage, the function rule is you're going to pay $2 for every hour that you spend in the parking garage. So your output is 2 times your input. Okay? And also your input usually the X, and the output's usually the Y. So a lot of different things. So X, independent value, and your input is one thing, and then Y, your output, dependent value, are the other thing on 2 columns. And then you can organize the input, output values, and the function rule in a function table. So it can be a vertical table or a horizontal table. That's what we're going to kind of look at a little bit more today. Okay? Okay, so this example, domain, range, those are the other 2 things I forgot about. So yeah, a lot of things I'm going to have to list it down, right? X, independent variable, input, domain. Y is also your output. It's your dependent variable, and it's your range. Okay, so the range is what it can be. So back to the definition of a function that assigns one output to one input. So here, one input, one output, one input, one output, one input, one output. That's a function. Okay. What's not a function is, see this -3 here? That's your one input, but it goes to 2 different outputs. It goes to 5 and 3. That is not a function. Okay. Everything else, that's fine, that's fine, that's fine. But if one input has 2 different outputs, automatically not a function. Okay. Here, this actually is a function. 2 to 3, 0 to 6, 3 to 9, and then 4 to 9 as well. That is still a function. You can have 2 inputs go to 1 output. That's totally fine. I made a separate video on this, or I might splice it in here, but I'll make it a different video as well, where I demonstrate this using a video game called Valorant, and you input and output on your computer. So that's still a function. you can put two different things and have an output of one thing. That's totally fine. And then not a function domain. So this looks like it's, oh, this looks fine, like the first one, but the for has no output. So that is not a function. Every input has to have one output. So that's not a function. Okay. So again, if you want more explanation on this, I made a kind of cool video of me being bad at playing Valorant, but bad because I made myself bad by messing up the settings and controls of my inputs and created a non-functioning game. So yeah, broke Valorant. Identify which of the following relations is a function or is not a function. So yeah, here you're looking at the inputs and outputs. So let's see, -3 goes to -2, -3 goes to 7. So if I have a -3, I have either -2 or 7. So this is not a function. Okay, here let's see, -4 to -3, -2 to -1, 0 to 0, 4 to 1. Yes, function. Okay, good. -6 to -1, that's fine. -2 to 1, 2 to 3, -6 to 9. There you have -6, and it has two different outputs. It has -1 and 9, so not a function. All right, and let's look at the last one. -2 to -1, 2 to 1, 7 to 2, -7 to -2. I don't see anything that's repeating anywhere. There's a lot of 2's and -2's, but this is going to be a function. All right. Okay, so moving on. Function, a rule or equation where there's exactly one output for every input. For every x value, there is exactly one y value. The other way doesn't have to necessarily be true. Okay, you can have, like I said from the previous example, you can have two different inputs to give you the same output. That's totally fine. Okay, so, and these are examples of some function tables, and let me just check if they're actually functions. So this is a function because everything has 1 to 1, right? And then let's check if this one's a function. 0 to 2, 0 to 0, 1 to 2, 2 to 4, 4 to 6. So automatically I'm seeing here, okay, I have the same output, but that's okay. -1 or 1 gives you 2. That's totally fine. That is a function. Okay, what's not a function would be something like this. 1 to -2, 0 to 0, 1 to 2, 2 to 4, 4 to 6. Here I have the same input of 1, but when you put an input of 1, you get two separate outputs. That is not okay. Right, so that's not an output. Okay, so today we're doing function tables. So the output is 7 more than the input. Complete a function table. Complete a function table for this relation. So my function table is x is the input, and then y is the output. And you don't always have to do this, but the function is actually 7 more than the input. So that means 7 more than is +7. Let me do this in a different color. +7 than the input. The input is x. So that's what I'm going to use there. So I can make a table. Okay. And then you can just make up any numbers for your input. So if it doesn't say what's used for input, I can just pick any. Usually I pick numbers that go in a certain order, like 1, 2, 3, 4, or 2, 4, 6, 8. So let's say 1, 2, 3, 4, that's fine. And then you would plug in your x for this x over here, and then see what you get. So 1 + 7, and your output is 8. 2 + 7 is 9, 3 + 7. Okay, and there, that's your function table. Again, this might be a little too easy for some of you guys, but like I said before, we're going nice and slow, so you're getting used to what a function is and how to complete a function table. Okay, so another simple one, complete a function table for this relation. So I have x is the input. I'm going to leave room for the function, and then y is my output. Okay, and then I'll say my function. The output is 5 times the input. So 5 times the input. My input is x. 5 times that, I could say that is 5x. Okay, so now I'll make my little table here. Maybe I'll try to make it a little neater. All right, so x, I'll pick any numbers. I'll pick 10, whoops. I'll pick 2, 4, 6, 8. Doesn't matter what I pick. 5x, so 5 times whatever x is. 5 times 2 is 10. 5 times 4 is 20. 5 times 6 is 30. And 5 times 8 is 40. And there you have it. That's your function table. Okay, and this is your function. 5 times the input x. Okay, and the last kind of example here is if you don't know what the input is, but you're given the rules over here. So this is saying, what did I do here? I multiplied something by 3 to get 6. So to the opposite, this is 3 times something to get 6. So you can do the actual opposite. You can go, okay, 6 divided by 3, that was 2. So my input was 2. Okay, same thing. 15 divided by 3, that's 5. Let's check that. 3 times 5 is 15, that's right, so my input was 3. And then 21 divided by 3 equals 7, so 3 times 7, my input was 7. So if it's asking for you what the input was, it's kind of like just solving an equation. You work backwards. If it said 3 times x, you work backwards by dividing by 3. Okay, so hopefully that was helpful on functions and function tables, and I'll see you guys next time.